Hey students, today we're working on lesson 4.2.1, how can I solve this system? And so we're going to walk through this Desmos activity together, so stick with me and we shall get started. And so we started out right away with this matching problem here. And so we have five different equations that we wanted to match up with, equations, right? Five different problems that we're matching up with equations. I'm just going to line these up so we can take a peek at them. All right. So we talked a little bit about this guess, check, generalize idea. And when I say guess, check, generalize, you can go back to Monday's video and I walked through it in a little more detail. But if you read what the question is asking, guess your answer, and then see how could that work. All right, and sometimes what happens is it starts to show you what the equation could be. So we're going to start with this one, Glenn, right here. And I need a way to write. So here we go. We're going to write Glenn bought a $5 coffee and 4 magazines at the airport. If he spent a total of $25, how much did each magazine cost? So what we're trying to answer is how much did each magazine cost? All right. So I'm going to just guess that each magazine cost $10. Again, guess doesn't matter, just try it out. And so if each magazine costs $10, I have 4 magazines times $10, but then I also bought $5 coffee, so I have to spend $5 more. Does that equal my total of $25? Again, I did that a little fast, but that's what I want you to think through. Well, what does it mean if each magazine is $10? It means 4 times 10. So that'd be 40 plus 5. Is 45 equal to 25? No. So it didn't work, but you see, my first guess was $10. So that was too much. Let's guess less. Let's guess $1. Well, if each magazine is $1, I have 4 times $1 plus 5. Does that equal 25? 4 times 1 is 4, plus 5 is 9. That does not equal 25. But do you see what we're doing? Any guess we have, we're going to have to multiply by 4 and then add to 5. So this is why we guess, right? We guess so that we can generalize our equation. And if I say, okay, let's guess X. If I guess X number, dollars, if the magazine, let X equal how much each magazine costs, then we just know we're going to say 4 times X plus 5. Does that equal 25? Well, now we can solve this equation. All right, so 4 times X plus 5 equals 25. This is what you can match it up to. Go ahead and solve that if you want to know how much each one cost. Subtract 5 from both sides. I get 4x equals 20. X equals 5. And it's not just 5, right? How much does each magazine cost? It costs $5. So that's guess, check, generalize in a nutshell, okay? Now I want you to try that out for the rest of these, okay? So guess the cost. In this one it says, how long did they use the kayak? Guess how many hours. All right, this one says, how many magazines did he begin with? Guess how many. This one says, how much did she have in savings before the trip? Guess a dollar amount. And then how much did each pack of markers cost? Guess. All right, we're going to do this Amani one here because I think that has a great way of guessing. So Amani spent a third of her savings on airfare for vacation. She then spent another $300 on hotels. If she has $250 left for meals and souvenirs, with how much did she have in savings before the trip? So she spent a third of her savings on the trip, okay? It says she spent another $300 on hotels, spent $250 on meals. So all of that's like tough to necessarily go through. But if you just say, with how much did she have in savings before the trip? Let's just say she had, I don't know, probably more than that, right? So let's say she had $1,000. And I'm going to even say $900, and I'll show you why. Amani spent a third of her savings on airfare for a vacation. So how do we find a third of that? We take our original amount and we divide it by 3. All right, so we have that $900 is divided by 3 as our airfare. So I got to get rid of that equal sign. I just want you to see. But then we also spent $300 on hotel. So we also spent $300 on hotel. Now this is where when you spend money, right, we're actually subtracting money. So some of these things are the skills that we're learning as we go through this. So her original amount minus $300, and we're left with $250. Okay? So does 900 divided by 3 minus 300 equal 250? No. But when I divide by 3, I get a nice 300 minus 300 gives us 0. Right? 0 doesn't equal 250. So you could do this again. Guess, maybe she had 1,200 because we could divide it by 3, or let's just say 300. And so if we have 300 divided by 3 minus the extra $300 she had, did we get to 250? All right. Well, we'd actually have 100 minus 300. That does not equal 250. And so we know that it would have to be more than 300. The whole point of this is we see our guess, some number x, over 300 minus another $300. We need that to equal 250. Sorry, divided by 3, not by 300. All right. So when you go back to the problem that we're looking at, and where are we at? Was it this one? Right. We're looking at this problem right here. We have this equation, x over 3 minus 300 equals 250. And so we did 2 of these, right? Glenn bought the coffee. Here's his coffee one. 4x times 5 equals 25. So go ahead and try the rest of those, and then you can always check your work to see if you got it. All right, we're going to go ahead a little bit here, walk your way through those. We're going to use something called the equal value method today. It's a substitution property, and so I want you to make sure you have that down. So write equal value method to solve system of equations in your notes. And here is some definitions for our system of equations. Notice we have 3 possibilities when we have a system. We either have one solution, no solutions, or infinitely many solutions. When they intersect on a graph, that's one solution. When they're parallel, that's no solutions. And then finally, this is the red and blue line on top of each other. It's purple. And that would mean infinitely many solutions because they're the same line, right? All right. So this first one, it says, so where is the solution on this graph? So you drag that point right here. And that solution is the point, if I can get it in the right spot, -4, 1. Okay, so -4, 1 is our xy value, right? It is the point where these 2 lines cross. So I'm typing that in there. 4 over 1 equals our x, y, okay, this intersection point is the solution to the graph. All right, so they have one solution, it's where they intersect. And so if you can graph them and you can find that point they intersect, that is your solution. This is one solution because they intersect at one point. So now it was your turn to draw -1, 3, 2 lines that intersect there. So pause this and go ahead and try that out. All right, so hopefully you could see this is the point -1, 3. Right, you go left -1, then you go up 3, and there's your point. Now use this line tool and you can say, well, here's one line that goes through that point, and here's another line that goes through that point, and that they both have this solution right here at, or their solution is -1, 3 because they intersect there. Your lines could be all over the place as long as they both cross at -1, 3. All right, so go ahead and explain what it means to be a solution, right? It's the intersection point. All right, here is one that you can do to match, and then go ahead and click on this to try. Keep going until you get it right. Again, you're going to have a bunch of them left over. These are the ones that a lot of people had trouble with. This black one right here is actually 2 lines, so that's infinitely many. This orange set, they're parallel, so there is no solution. You make sure you try the other 4, and it should be 1 card to 1 card, okay, and then click it. All right, so now let's move on to the next part of this, where we're substituting using that equal value idea. And you can see that we can walk through this solution right here, and we have y equals 3x and y equals 5x minus 8. We take those and we set them equal to each other. So 3x is equal to 5x minus 8. And then we're just going to solve for x. And so what we end up doing is we keep going, and you can do this a couple of different ways. But you get x equals negative, or 8 equals 2x, divide both sides by 2, and you get x equals 4. Then you choose one of these 2 equations, all right? You plug 4 back in. 3 times 4 is 12, and so we get y equals 12. And so our point here is the point 4, 12. That would be your solution and your point on the graph. We're going to go ahead and we're going to skip to this next one. And I want you to try this problem right here. Solve the system y equals 17x minus 6 and y equals 12x plus 44. So try that out on slide 17. Pause your screen right now, all right, and come back and see the solution. All right, hopefully you were like, all right, 17x minus 6 equals 12x plus 44. Set them equal to each other. Then let's get all of our variables to one side, all of our constants to the other. I always like to do this. I see a negative, I'm going to add that to both sides. And what am I left with over here? 17x minus 6 plus 6 just gives me 17x. 12x plus 44 plus 6 is 12x plus 50. Now I want to get this 12x to the other side, so I'm going to subtract it from both sides. And I get 5x equals 50. 5 times x, I undo that by dividing by 5. So I'm going to divide 5x by 5. I'm going to divide 50 by 5, and I get x equals 10. Now, so many people just are done there, except if I want my solution, which is a point, I only have half of that point. I need to find what y is. And in order to find y, plug it into either the top equation or the bottom equation. I'm going to pick the top equation, y equals 17, my x is 10, minus 6, and I get 170 minus 6, which is 164. Well, maybe you wanted to try the bottom one, so let's just show you quick how that works. Y equals 12. My x value is 10, and I get 12 times 10 is 120. 120 plus 44 is 164. Boom. So no matter which equation you plug back into, you should get the exact same value. And now we're cooking with the... Now I want you to work your way through as many of these as possible. I'm going to give you the answers here. I'm going to hit pause, but the next 45 seconds of this video are going to be the answers. So make sure you try them out, then go do your Delta Math homework. All right, so here's 3 solutions if you worked it through on slide 19. Look at this work. You can always pause to look at it. You get -7, -5 as your xy value. Go ahead and slide 20. You would plug -1, 3 into both equations to see if it works. But since it only works for the second equation, it's not a solution. Finally, your solution is 7, -1. Go to your Delta Math assignment, and you can have videos, and you can have some more practice. Good work.